What if the very path we forged to the stars was built on a fundamental misunderstanding? For generations, the engines straining against Earth's gravity were monuments to a terrestrial struggle. We accepted a Christmas tree of wires and shields, each connection a whisper of potential failure. This intricate dance of thousands of individual components, a testament to meticulous, artisanal assembly, was the pervasive lie. We believed power demanded perceptible complexity, that the journey to the void must be burdened by limits we ourselves created. But the cosmos, in its vast indifference, had other ideas. And now, a brutal elegance has emerged. This is SpaceX's Raptor 3. It is not merely an engine. It is a profound metamorphosis, a design stripped bare by an unforgiving necessity. The complex layers of Raptor 2 are gone. The external hardware, once a vulnerable skin against the cosmic elements, vanished. External wiring, once a delicate spiderweb, disappeared. Even the heavy heat shields, long considered indispensable, have been eliminated. This brutal shedding of parts is a testament to something deeper: improved reliability and a critical reduction in mass. The engine itself seems to have evolved, acknowledging the stark reality of the vacuum it is destined to confront. The true heart of this transformation, however, lies unseen. It is embedded in the very fabric of its being: advanced metal 3D printing. Using laser powder bed fusion and direct metal laser sintering, Raptor 3's components are not assembled, but birthed. Each layer is agonizingly thin, finer than a human hair, meticulously refined over approximately 24 hours. This advanced manufacturing marvel allows complex internal channels to be woven directly into its core structure, merging what were once disparate parts into seamless, integrated systems. The pervasive lie of requiring thousands of individual components for a rocket engine is now obliterated. A new truth, cold and precise, has taken its place: fewer parts, less weight, higher reliability. These are the very principles that govern the efficiency of cosmic phenomena. Within these newly integrated internal channels, the very propellants undergo an alchemy. Cryogenic fuel no longer merely ignites, it becomes an agent of its own protection. It absorbs heat before combustion, actively cooling the engine from within. This internal resilience allows for chamber pressures around 300 bars, enduring temperatures exceeding 3000 degrees Celsius, all with fewer traditional protective systems. Such durability is born from a proprietary material, the SX500 superalloy, engineered specifically for extreme strength and oxidation resistance. It pushes the boundaries of what matter can withstand in the face of absolute energy release, a material capable of holding back the inferno. SpaceX orchestrates a hybrid manufacturing symphony to achieve this. Direct metal 3D printing sculpts the most complex geometries, like the combustion chambers themselves. Simultaneously, advanced investment casting fortifies the higher density structural parts. This is more than engineering, it is an industrialization that stares down the infinite. It moves from slow, meticulous craftsmanship to rapid mass production. It accepts the brutal truth of the cosmos: evolution is an endless, unforgiving iteration. Data from morning static fire tests informs design revisions by evening, ready for immediate printing. This relentless cycle of creation, testing, and refinement mirrors the indifferent, ceaseless march of cosmic evolution itself. The universe demands speed, purity, and strength. Raptor 3 answers, not with an echo, but with a roar forged in the fires of relentless redesign. If this brutal elegance works here, what other cosmic burdens are we still carrying, unaware of their true nature?